What if the universe did not have a beginning? Scientists now question the Big Bang Theory. Reality is sometimes like science fiction or even a fairy tale, Bruno Bento says, a physicist at the University of Liverpool. He's engaged in a new direction in the theory of quantum gravity, causal sets. It's based on the hypothesis of the discrete structure of space-time and the partial ordering of its points. Applying this approach to the study of the beginning of the universe, he and his colleagues discovered that the universe could exist forever and the Big Bang is only one of the stages of its evolution. Quantum physics describes 3 or 4 fundamental interactions of elementary particles. General relativity, on the other hand, has developed the most complete description of gravity, but at 2 points or singularities, it doesn't work. At the center of a black hole and at the beginning of the universe, there gravity behaves differently from the rest of the universe. To solve the singularity puzzle, physicists need a quantum theory of gravity, that is, to understand how it behaves on a microscopic level. There are several approaches, in particular string theory and loop quantum gravity, but scientists from Liverpool have proposed a new option, Science Alert writes. In all modern physical theory, space and time are continuous. They form the smooth fabric underlying all reality, but there is another point of view representing space-time in the form of separate segments or atoms. In this case, there is always a gap between the two closest events. The theory of causal sets cleverly gets rid of the singularity problem because it says that matter cannot be compressed indefinitely. It cannot become smaller than the size of the atom of space-time. In other words, there is no singularity. Bento and his colleague, Stav Zalel of Imperial College London, viewed the events of the Big Bang in terms of causal sets. And Bento said, in the original formulation dynamics of causal sets from the classical point of view, causal sets grow out of nothing into the universe known to us. In our work, there is no Big Bang as a beginning because the causal sets are drawn into the past without end, and there is always something that was before, Bento said. Thus, physicists argue that the universe did not have a beginning, it just existed forever. What we think of as the Big Bang is just a single moment in the evolution of the causal set. Many questions in this hypothesis still remain unanswered. For example, it's not clear whether this causal approach allows for the existence of physical theories that describe the complex evolution of the universe during the Big Bang. A group of physicists from Denmark, with the help of the Large Hadron Collider, learned a little more about how it all began and what happened to the special kind of plasma, the first matter in the universe, during the first microsecond of the Big Bang. They reconstructed what happened to the quark gluon plasma in the first 0.00000001 second. This is on Solask. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.